All right, Calculus BC friends. I promised you all at the BC Summit that I would record solutions for 2 more polar questions and then ship those out to you guys. This took a little bit longer to get to than I thought, and for that I apologize, but I'm here finally. This question is from the 2017 AP exam. This is last year's question. This is what you would have faced. This is question number 2. It's calculator active. This is what would have been staring back at you, either moving you closer to your goal of a 5 or holding you back. The figure above shows the polar curves r equals f of theta is 1 plus sine of theta times cosine 2 theta, and r equals g of theta, which is equal to 2 cosine theta, for the interval 0 less than or equal to theta less than or equal to pi over 2. Let r be the region in the first quadrant bounded by the curve r equals f of theta. So f of theta is the boundary for this guy here and the x-axis. Let s be the region in the first quadrant bounded by the curve r equals f of theta. Bounded by the curve r equals f of theta, r equals g of theta, and the x-axis. Gotcha. So f of theta is the inside curve, g of theta is the outside curve, and s is all the stuff in between those two, which I just shaded in green. In part A, we're asked to find the area of R, and I would hope that part A is a pretty standard question. We know that the way we find area in polar, it's 1/2. You integrate from alpha to beta, your radius squared d theta. Now what's the radius? The radius for region R, think about all those little sectors. You're starting out at the origin or the pole, and you're going all the way out to the curve. In each case, the length of that radius is defined by f of theta. So that's going to be my radius. My starting angle, I'm going to start over here at theta equals 0. I'm going to end over here at theta equals pi over 2. So my integral is going to be 1/2. Integrate from 0 to pi over 2, f of theta squared with respect to theta. Now, fortunately, this is the calculator active part of the test. You don't actually have to do the integration. You just need to do this on your calculator. So let me switch over. Now, what I did, and unfortunately the way my screen's set up, let's see if I can get everything in there. Yeah, the program's behaving a little bit differently. There we go, that'll work. Okay, so I already went into my graph, and I graphed for f1, 1 plus sine of x times cosine of 2x. That's f of theta. For f2, 2 cosine of x, that is g of theta. Keep in mind, I could graph in polar if I wanted to, and what I would get on my screen matches exactly what I see on the paper perfectly. But when it comes to the computations, it's actually, I find it a lot easier to just have your calculator graph in rectangular mode, do the calculations in rectangular mode, and go from there. So now that I've got both of those graphed, I'm going to go over here, and I'm going to type in 1/2 times, to do the integral, menu, calculus, numerical integral, from 0 to pi divided by 2. Now I need the radius squared. My function is in terms of x. I'm going to integrate with respect to x. And it's f1 of x that gets squared. And what did I get? I've got 0.648. I am totally going to cheat and look at the College Board scoring rubric. 0.648 is the right answer. Now let's go back here. That means that my area is 0.648. How did they award points? They said 1 point for knowing how to do the setup with the integral, 1 point for coming up with that numerical value. That is 2 points, and earning 2 points on a polar question, that is a pretty good start. Let's see what else we can do. In part B, the ray theta equals k, where k is between 0 and pi over 2, divides region S into two regions of equal area. Two regions of equal area. Write but do not solve. Oh, how do I love that phrase. An equation involving one or more integrals whose solution gives the value of k. They don't want me to find k, they just want me to find the ray theta equals k that divides region S into two regions of equal area. Well, let's see, I'm going to need some room here. And where's my ray? Okay. A ray is, remember, like you have a definite starting point, but then it goes on forever. They said the name of the ray is theta equals k. And what's so special about this ray is it divides region S, that's the green piece, into two regions of equal area. Well, if the regions are going to be equal, then that means that the area from 0 to k and the area from k to pi over 2 are going to be equal to each other. So 1/2, I'm going to do an integral from 0 to k of some stuff, is going to be equal to 1/2 the integral from k to pi over 2 of some stuff. Now I've got to figure out the stuff. Okay? So I'm going to integrate from 0 to k, and I want just this area. Well, you might be thinking, oh, do g of theta squared. The problem is that would treat g of theta as the outside curve. That's a good thing, but then you'd find all of this area, including the part that's inside of r that I don't want. What are you going to do? You're going to subtract that out. So minus f of theta squared d theta. What about from k to pi over 2? Same thing. G of theta squared minus f of theta squared d theta. That's it. This was worth 2 points. They awarded 1 point for the integral expression for one region. Meaning if you had this correct, or if you had this guy here, you earned the first point. Setting the two of them equal to each other in an equation that makes sense earned you the second point. It's a grand total of 2 points. So far, I'm feeling pretty good about this question. Let's see what else they've got in store for us. In part C, says for each theta with 0 less than or equal to theta less than or equal to pi over 2, let w of theta be the distance between the points with polar coordinates f of theta comma theta and g of theta comma theta. Write an expression for w of theta. Then, because that's not enough, find w sub a, the average value of w of theta over the interval 0 to pi over 2. Oof. Okay. I need to think about this one. For each theta, where theta is between 0 and pi over 2, let w be the distance between the points. But okay, well, distance between points. And here's where you need to think a little bit differently because you're in polar. If I wanted to find the distance for a fixed angle, let's say this guy right here, theta, I need to know this point, and I need to know this point, and I need to know the distance between them. Well, how do you find the distance between them? You might be thinking, well, let's use a distance formula. But you're in polar mode. For a particular angle theta, you already know how long this radius is. You already know how long the big radius is. The way that you're going to find the distance, so your distance, which we're calling w of theta, is just going to be the length of the big radius minus the length of the small radius. So g of theta minus f of theta. Okay. Write an expression for W of theta. Check. Find W sub A, the average value over the interval 0 to pi over 2. Okay, well, maybe that's not too bad. Remember the way that you find average value in calculus class? We did this in AB a lot. The average value of a function over an interval AB, you find the integral of that function from A to B, divided by the length of the interval, which is b minus a, or in this case, 1 over b minus a. So the average distance for 0 less than or equal to theta less than or equal to pi over 2 is going to be 1 over pi over 2 minus 0. The integral from 0 to pi over 2 of w of theta, that's g of theta minus f of theta d theta. Don't be scared. All we're going to do is we're going to type this into the calculator. Calculator is going to do the work yet again. So let's do this. 1 divided by parentheses pi divided by 2 minus 0 if you want to. Clearly you don't have to do that. Times menu calculus numerical integral from 0 to pi divided by 2. Now I need g of theta, that was my second function, minus f of theta, that's my first function. Integrate with respect to x, and we get 0.485. I'm going to go back, and this is approximately 0.485. Now, where did the points come from? 1 point for the expression for w of theta, 1 point for the integral, and 1 point for the numerical answer, for a grand total of 3 points. Even part C, not too terribly bad. Hopefully at this point, you're starting to kind of get the hang of things in polar, feeling a little good about yourself. Let's keep going. One more part. Part D, using the information from part C, find the value of theta for which w of theta equals w sub a. Is the function w of theta increasing or decreasing at that value of theta? Well, what do we know? We said w of theta was, what was w of theta? G of theta minus f of theta. Let me scoot this up. W sub a, that's your average value, we determined is 0.485. I'm looking for the place where w of theta is equal to 0.485. Okay. I need g of theta minus f of theta equal to 0.485. Remember, this is calculator active. We're going to go back to the calculator. I'm going to look at my graph because I like to use my graph to solve equations. I've got a graph for f1, which is f of theta, a graph for f2, which is g of theta. What I need to do is create a third graph, and that third graph is f2 of x minus f1 of x. Remember, that's g of x minus f of x. That's the black graph. And I want to figure out where this is equal to 0.485. So I'm going to then type in the horizontal line, y equals 0.485. Now, as you can see, it's getting a little tough for me to see things. So I'm going to change my window settings. And I'm going to leave xmin and xmax alone, but I'm going to change the ymin and the ymax, maybe -1 to 1. Okay, I'm going to grab some of these guys out of here because they are just clogging up my screen. For me, the black graph is f2 minus f1. The purple or magenta maybe, that horizontal line is y equals 0.485. I want this intersection point, so menu, Analyze graph, intersection. I've got to identify the two graphs, identify the region, and I'm getting 0.518. Okay, so that means that the angle that I'm interested in is 0.518. Now, lastly, they wanted to know, is W of theta increasing or decreasing at this point? If you're in Calculus BC, you know that the way that we determine if something's increasing or decreasing, we look at the derivative. So I'm going to menu, Calculus, numerical derivative. I'm interested in 0.518. I could have chosen to store that as a value. That would have been smart. I need the derivative of g of theta minus f of theta. You could type it in as f2 of x minus f1 of x. I'm going to type in f3 because that was how I named the function. And I'm getting negative 0.581. Well, let's go back here. We set this equation equal to 0.485. We solved it, and what we found is w prime at 0.518 was negative. What does that mean? This means that the distance is, what's it doing? Is decreasing at theta is approximately 0.518. And all they awarded was 2 points for all of this work. 1 point for coming up with theta is 0.518. 1 point for your conclusion. You determined the value of the derivative to be negative. That means that the distance is decreasing. That was your second point for a 2-point question. Not a horrible question, a little scary. Let's be real, it's a little scary. There was a whole lot of reading going on here. I think it's a very intimidating question when you first look at it. You've got two completely different functions, but if you just stick with this, if you know your formulas, you're going to be okay. Okay, so let me scoot that off on the side. And the last question that I want to do with you guys before I turn in or go have some dinner, this came from the 2009 exam, so a little older question. In fact, I just did this one in class today with my North Side students, and for the most part, they did a good job. What I really like about this question is it's question number 4, which means no calculator. I will tell you, it is rare, super rare, for the College Board to create a polar question and have it be on the calculator inactive part of the test. Usually they're going to go with more complex functions. You're going to do a lot of calculator work. Let's look at this question and see what we can do. The graph of the polar curve r equals 1 minus 2 cosine theta for the interval 0 less than or equal to theta less than or equal to pi is shown above to the right. Let S be the shaded region in the third quadrant bounded by the curve in the x-axis. A, write an integral expression for the area of S. Now, we know how to find area. We're really good at this. It's going to be 1/2 an integral. You take your radius, which in this case is 1 minus 2 cosine theta. You square the whole thing and integrate with respect to theta. The struggle my class was having today was in identifying the starting point and the ending point for region S. And I think the tricky part, the issue is that just generally speaking, we don't do enough work with polar curves in pre-calculus. The students aren't really sure how to approach this. You're told that this is true for 0 less than or equal to theta less than or equal to pi. So you might say, well, then how the heck do we get over here in region S? Well, what happens at theta equals 0? If theta is equal to 0, your radius is 1 minus 2 times the cosine of 0. Cosine of 0 is 1. 1 minus 2 times 1, you get that the radius is -1. Remember how you plot points in polar. You set the angle first. For us, here's the way the marker's pointing. Theta is equal to 0. The radius tells you how far away from the pole to go. Well, at theta equals 0, I should be going to the right, but my radius is negative. That means you flip the pen around and you're going this way. So this point right here is actually where you are at theta equals 0, and the radius is -1. That's your starting point. Theta equals 0. What's going to happen is as your radius increases, your point is going to move along the curve until you get right here. Where is that point? Well, what's so special? You don't know what the angle is this time, but I think you know what the radius is. The radius is equal to 0. So what you're going to do is you're going to take your equation 1 minus 2 cosine of theta and set that equal to 0. You can solve this equation for theta. -2 cosine theta equals -1. Cosine of theta is equal to 1/2. Where is the cosine equal to 1/2? I'm sorry, equal to 1/2. That's going to be at theta equals pi over 3. That's your upper limit. Theta equals pi over 3. And no, we didn't actually have to do a computation here because it's calculator inactive. They awarded the points. This was a 2-point question. 1 point for the integrand, 1 point for the limits of integration and the constant. So part A is worth 2 points. I know we struggled a lot today figuring out the starting and the ending angle, but I would encourage you to come back and take a look at this again. Okay. All right, part B. Write expressions for dx d theta and dy d theta in terms of theta. Dx d theta is the derivative of x with respect to theta. Dy d theta, of course, is the derivative of y with respect to theta. Well, how can I figure out what x is? How can I take a derivative if what they gave me was the radius? You need to keep in mind the relationship x equals r times cosine of theta and y equals r times sine of theta. In this case, since we know what r is 1 minus 2 cosine theta. So x is that expression there. Y is 1 minus 2 cosine theta times sine theta. Dx d theta just means go take a derivative. I have 1 minus 2 cosine theta times cosine theta. For students in a Calculus BC class, I would assume that this is pretty straightforward. Take the derivative of the first, that'll be positive 2 sine theta. So derivative of the first times the second, plus now you leave the first alone, times the derivative of the second. For dy d theta, again, product rule, derivative of the first is 2 sine theta, leave the second one alone, plus the first times the derivative of the second. That's it. That's all you needed to do. Let me double check. Write expressions for dx d theta and dy d theta in terms of theta. They awarded 1 point if you had the relationship x equals r cosine theta and y equals r sine theta. If you correctly found the derivative of the radius here or here, anywhere at all, another 1 point. For finding the correct expression for dx d theta, 1 point. Correct expression for dy d theta, 1 more point. Y'all, that was 4 points. 4 points in part B. Love it. Love it, love it, love it. High scoring question. Part C, write an equation in terms of x and y for the line tangent to the graph of the polar curve at the point where theta equals pi over 2. Show the computations that lead to your answer. Okay, I want to move this up here. So we want equation of tangent at, what was it again? At theta equals pi over 2. Well, equation of a tangent line, you've seen this a lot. You need a point and you need the slope. Where do we get the point from? You need to know the x and the y coordinates when theta equals pi over 2. One way you could do that is you could say, okay, well, I know that x is 1 minus 2 cosine theta times cosine theta. So your x value is 1 minus 2 cosine of pi over 2 times cosine pi over 2. Y is 1 minus 2 cosine of pi over 2 times sine of pi over 2. That's your x coordinate. That's the y coordinate. Now remember, you're on the free response part of the test. There is no need to simplify these answers. They're all numerical values. But let's give ourselves a little bit of trig practice, but you could stop here. The cosine of pi over 2 is 0 times 2 is 0. 1 minus 0 is going to be 1. We get 1 times cosine of pi over 2 is 0. Maybe you expected that, maybe you didn't. Cosine of pi over 2 we said is 0, times 2 is 0, 1 minus 0 is 1, times sine of pi over 2, you get 1 times 1, that's 1. So the point that you're interested in is 0, 1. Now look at the graph. If your angle is pi over 2, whoop, what's the x coordinate? 0. What's the y coordinate? 1. You could have gotten it from the graph as well. Don't feel bad if you missed it. It's all good. What else do you need? You need to know the slope. In polar, you find dy dx by doing dy d theta over dx d theta. We need dy dx when theta equals pi over 2. So I'm going to take my dy d theta expression and plug in pi over 2 for theta. And then in the denominator, you're going to go to dx d theta, and everywhere you get a theta, plug in pi over 2. Okay, let's take advantage of the fact that we've got some trig skills here. 2 times sine of pi over 2. Sine of pi over 2 is 1, times 2 is 2, times sine of pi over 2, 1, plus cosine of pi over 2 is 0, times 2 is 0, 1, okay, 1. Cosine of pi over 2 is still 0. I made a really big fraction bar for no good reason. Now plug in pi over 2 for theta over here. Sine of pi over 2 is 1, times 2 is 2, plus 1 is 3. The cosine of pi over 2 is 0, plus cosine of pi over 2 is 0, times 2 is 0. 1 minus that is 1. Negative sine of pi over 2. Sine of pi over 2 is 1. The negative of that is negative 1. So I've got 2 over negative 1, which is negative 2. This is your slope. This is the point. L of x is going to be negative 2 times x minus 0 plus 1. Y'all, that's it. That's the end. Now, how did they award points? If you came up with the values for x and y, the simplified or these unsimplified versions, 1 point. They then said the expression for dy dx, I think that's this. You knew that dy dx was dy d theta over dx d theta was the second point. And then equation for the tangent line was your final point in a 3-point question. I hope what's becoming really clear as you're working through these two polar questions is that a lot of what's going on in polar, you need to know these other equations that we're working with. And it should be pretty manageable for students in a Calculus BC class. Don't be scared by polar. You've got your calculator, you've got your smarticle particles, all will be well. I hope this helped.